Hi, this is Karen O'Brien, and we have just finished up with part 1, 2, and 3 of the hydrology getting started and learning how to do a backup model. And now we'll be moving on to the channels. So the channels lesson uses a RAS import, but if you don't have a RAS import or you don't typically work with RAS, you might want to check out some of the other lessons. The channels urban channel is the same lesson as this, except it applies a 3-part channel where let me get down here to a picture, where part 1 down here in the first segment is rectangular, part 2 is trapezoidal, and part 3 is natural. So it's kind of a bit detailed. It's a bit more complicated, but it has a lot more detail on how to manipulate and create data for urban channels. Or if you want to do something a little bit simpler or see a different way to create a channel, we have the coastal channel right here that is used to natural channel geometry the whole way, and it just a single channel segment for a different way to set up hydraulic structures using just the single segment. So that's the other option. So I'm going to go back to lesson 2 and we'll go over what's in the lesson. So we have the geo package and QGZ that is coming from lesson 1, part 3. The inflow hydrograph for the Greenway Inn, it's a 24-hour 100-year hydrograph. The culvert tables and the geometry file coming from RAS. So this was a GeoRes project, or you could make it with RAS, the most recent RAS tools. The channel's already made for you, don't have to do that. So we'll start by, well, let me show you. Here's the data right here. So back in QGIS tutorials, here's the RAS data here. Just need the geometry file out of that. Hydraulic structures are just 2 text files. And here's, of course, the export folder for the test runs and the inflow hydrograph here. So the start will be to open QGIS and load lesson 1. And I've already done that. In addition to that, you'll need the aerial for this. So if you don't have quick map services, remember the aerials are available in lesson 1. And cleaning up the map, so we don't want the infiltration layers turned on, and we don't need any of this project data for the time being. The next step 2 will be to import the RAS geometry. So that's just this button here. Make sure to set it to bank stations and point it to the geometry file, and it should look like this. So I'll go ahead and do that now. And here is the import RAS button. And again, bank stations, and then we'll point that to lesson 2 HEC RAS channel and grab the geometry file. Click OK to import it, and it should look like this. And of course, if you don't have any errors, it should come in like this. So in the RAS data, this would be called reach 1, or I think I named this G1, G being the reach, and 1, I can't remember how that works exactly, but if you open up the RAS data, you would see how that works. So G1, G2, and G3 would be reach 1, reach 2, and reach 3. That's how you do that with the RAS, just 3 individual reaches. Or if you want to do them all in a single reach, then you go to the coastal lesson to learn how to set up hydraulic structures a little bit differently. But we're going to focus on this method where the reaches are split at the hydraulic structure. Okay, so back here in the lesson, we now go on to step 3, which is to schematize the channel, which will convert it from user layer data to Flow2D ready data. And if you see this error message, the schematization worked correctly. So I'll just open the cross-section editor and click the schematize button and click close on the message. And what you'll see, I'll come back over here to the user layers and turn off the left banks. And I meant the left bank, right bank lines, and the cross-section lines. And you can see here that this is a Flow2D ready channel where it has an individual cross-section for every left bank in the downstream directions. Now, sometimes left banks can share a right bank, that's okay, but typically like in this channel, they don't really need to share. It's just the way that the cross sections are set up kind of forces them to, but it's okay for the lesson, it's fine. Now, let's go ahead and see what the next step is. So the next step will be to apply the upstream boundary condition. So in this channel, we have an inflow condition with a inflow hydrograph and an outflow condition that sets or allows a normal depth downstream boundary control that is applied to the cross section. So we'll zoom into the cross section and then use the boundary condition editor to create an inflow point. Then we'll save that point and fill the data in using the GIF. The data is coming from the text file, and it's just like the boundary condition from lesson 1, except we're going to be applying it to the bank. And then on the downstream side, we'll be doing the same thing, grabbing the point layer and clicking the last bank, and then changing the table to outflow, and then saving it in the widget and filling out the forms on the outflow side of the widget. So we can do all that now. So I'll start by going to the upstream side of the channel, and what I need is the boundary condition editor, and I want a point boundary. I'm going to apply it to the left bank, but as an inflow node, but it's going to actually be applied to the whole cross section because the cross section is tied to the left bank using a cross section number identification variable. And then back here, I'll click Save and click OK. And here is the current node. And now we just need to fill out the rest of the data. Over here, I'll click the Name tool and we'll call this Greenway In. And it is a channel inflow node because it is defined to put the inflow hydrograph to the cross section, not the grid element. It's a inflow hydrograph, not a diversion, so we'll leave that alone. And this needs to be updated to a different value. So we'll change this by adding a new time series. And the time series 2, we can rename that to Greenway in 100 year 24-hour. That's just the name of this particular hydrograph. And the hydrograph data is in the inflow hydrograph here in the text file. And this is control. Just hold the control button down and you'll be clicking A, or not clicking, but pressing A to select all, C to copy, W to close the file. I'll go ahead and do that one more time. Control A, C, W. You don't have to, oh, sorry, A, C, W. You don't have to let up on that control button. Now I come over here, put my cursor in the first cell and click paste. And you can see that we have the hydrograph that comes into this point. This one is complete. So now we'll go to the other side of the channel, to the downstream boundary. And we're going to kind of repeat the process a little. So it'll be click the point button and then click the left bank, the last left bank. And this changes from inflow to outflow and click OK. And then again, back here, we'll click Save and OK. But now we need to switch to the outflow side of the table. So this we'll call Greenway Out. And this outflow type is, you can either use 2 or 3. So because we have rainfall, I will use 3. But if you don't have rainfall and you don't anticipate overbank flooding, you could use 2. But anything, this will cover both the floodplain elements that share with the bank and the channel cross section. And again, it is a normal depth discharge off the edge of the grid. If you have anything other than normal depth, you have to set up a table or time series data for that. Now we're finished with that. So the final step is to click the Schematize button to commit that data to the Flow2D user data, or sorry, schema data. So again, that's the Flow2D ready data. And when I click the schema button, if I go to the other two features, you can see that they also have been updated. And if I change to the other inflow node, Grover in, you'll see not only is the inflow node updated or in the correct location and assigned, but also the curve changes a little bit between the two. There's a slight change between the two. Okay, and that's the end of that, of setting up the boundary conditions. So let's go ahead and go back here to the tutorial, and the next thing is to set up the culverts. So we have two culverts in this channel. One will be here and one will be here. We'll call these from upstream to downstream, Greenway 1 and Greenway 2. You can see them here. This is the zooming into the culverts and digitizing them. And so what we'll do is collapse the widget and then click the structure editor, select the structure line creating digitizing tool, and start digitizing the channel. So that the process is to left click the upstream left bank and then left click the downstream left bank. That will make the connection. Right click will complete the line, and then OK to complete the structure. So it's pretty simple. Go ahead and try that. Oh, well, then you come back to the table, click Save, fill out the table using the images here to finish filling out the data, and then load the rating tables into the project, and then use the Schematize button. So let's go ahead and do that now. So we'll zoom into the upstream side of the channel, and what I want to do is just to turn this off just so you can have a better view of the structure, or the way this is set up. And if I come here to the structure editor and use this guy, that's digitize a line, I can click anywhere in this cell, but it has to be left bank to left bank. So I'm going to just show you left bank to left bank, and then I'll right click that and click OK, and then move to the next one. And this one I'll show you. I'm just going to kind of click a little bit closer to the center of the node, and I'll show you the difference. Left bank, right click, and then click OK. And now that one is finished. Back over to the table, we click Save, and then we can start to fill out the data for each structure. So if you want to use the center button and then switch between the structures, it will reposition the map. So I'm going to call this one Greenway 1 because that's the name of the rating table that I want to import for it. It is channel-to-channel structure, meaning that the structure or the rating table is applied from the upstream cross-section of the channel to the downstream cross-section of the channel. Floodplain to floodplain is pretty obvious, but you can also do floodplain to channel and channel to floodplain for hydraulic structures. We'll change it to a rating table because I don't have the curve data, I just have a rating table data. And then we'll move down to, don't need anything else down here. I'm not going to use a tailwater control on this structure because there's a pretty big drop structure at the end of both of them. So I'm just going to leave this to no tailwater effect. And reference elevation for the headwater, don't need that because as the water comes and touches the invert of this cross section, it's going to start flowing through the structure automatically. So this can be just left off by leaving it at 0. I also don't need a conduit length or width for this one because the culvert's pretty short. So what's going to happen is it will be an instantaneous exchange from the upstream side of the culvert to the downstream side of the culvert. And let's go ahead and move down to the next one. This one is Greenway 2 and channel. Rating table, and everything else is the same. And the final step will be to import the rating tables. And you can see here that they both have the name Greenway 1 and 2. That's important. They have to match these names right here. Click OK, and they will now be assigned to the two structures. So you can, and you can't really tell unless you switch back and forth between the two of them. And you can see the rating table changing down here and the name of it as well. Okay, so now the final step is to click the schematize button. So I'll do that. And what happens is the flow 2D data is just automatically assigned to the center of the node from the upstream to the downstream condition. So it doesn't really matter how close you get with this cross section, as long as you're inside the grid element that you want to set up the exchange for. You can be slightly off center, that's okay. And then of course you saw that I put this one a little bit closer to center, so you can see that those two are a little bit more in line with each other. That's not super important. I just want to show you how that works. And so now structures are complete. So I'll close that up. And the next step, it's not the final step. The next thing we'll do is interpolate the channel data. So the channel interpolation, you'll basically you'll use this button right here to export the chan.dat, chanbank.dat, and exec.dat. And then those three files will be read by the cross-section interpolator program. So you have to export them to a specific location. And then the button says they'll be written. And then you'll run the interpolator.exe, and that will update these three files with the fully interpolated cross-section data. And then the final step will be to bring that data back into QGIS so that it's now part of the geo package. And I'm going to minimize this, and we'll go ahead and do that. So we need the cross-section editor, and we also need the lesson to export folder so we can see timestamp change on these guys. So the first step will be to start the interpolation process by selecting the export folder. And the message states that the three files were saved, and you can see them right here: chan.dat, chanbank.dat, exec.dat, and they have a timestamp of 2 p.m. And I click OK, and now I have this tool, which this should already be set for you, but you might have to set it on the first time. But it should have been, this path should have been set up and identified in lesson 1. So if you don't see it, you'll just click on this button and go to C Drive Program Files x86 Flow2D Pro. And then this one was set when we did our export of the three files, so it should also be in the correct location. But again, if it's not, you'll use the buttons to set it to the correct location. Then you use the interpolate button, and now if we come over here, a couple of things have happened. The timestamp on the two files that were changed is now updated because the interpolator program worked, and the channel cross-section geometry output file is here, and it has some detail about the individual cross-sections, like area, top width, things like that. And so then the final step will be to import these three updated files back into the geo package. And now the system is fully interpolated. Let's go ahead and go on to the next step. The next step is to export the project, but of course the first thing we'll do is make sure that our switches are all turned on, and then we export the project from the GDS button, and then we will, let's see, so in this case we use all the buttons, and then we see that the message appears, and then we'll move on to step 8. So step 9, first thing we'll check is that our two switches are on. We have two new processes, so we need the main channel process and the hydraulic structures process. Everything else is okay. At this point, you could change to detailed graphics if you wanted to watch the model run and watch what's happening on the grid. But again, I kind of just like to keep it at text screen because it's just a little bit easier to review, or it's faster. Then I click Save, and I'm going to now do step 8, but of course step 8 has an error in it because two of our bank elements are a little bit too close together. So this will show us how to set up the test run and review the error message, and then this video will show you how to fix the error, but also I'm going to show you in the video that you're currently watching. So That process, oops, sorry, I didn't need to do that. That process will look something like this. Export the data. That's got to go back into Lesson 2 export. And we need everything this time. And then click OK. And then run the simulation. And it is also still good because of what we just did, and Lesson 1 fixed this path, and what we just exported fixed this path. So I click OK, and you can see that the lesson has started. Now it says here, hey, there's some errors in your data. Please review your data files. The two data files it tells you to check is error.check and storm drain error.check. Well, we know we don't have a storm drain yet, so we can ignore that part of the message and just click OK and let it finish its turning off or shutting down. And then we come back here, and there is the error.check file. So how can you find it quickly? If you are sorted by type, it'll be a CHK file. You want to open this with Notepad, so if you right-click it and you click Open With, you should be able to set that to Notepad and always use that app to do those kind of files. Or you can open it with Notepad++. That's also a good way to watch or to review this data. So I'm going to double-click it, and there's a little bit of information in here in our channel. There's the error message here, and I'll get back to that in just a second. And then there are two notes. Now the notes are just letting us know that these two channel elements have hydraulic structures assigned to them, so that they will no longer need try to exchange with the grid system that's just downstream of them, or just upstream or downstream of them. Instead, they will be exchanging through these structures. And this is grid element 4508. This is your actual error. So it says the remaining floodplain surface area on the channel bank element needs to be larger. Basically, that's just saying that the two channel banks are a little bit too close together. We're going to copy that grid element number and put it in the grid ID tool for, and again, that was this guy right here. And it should, for you, it should be right up here. You shouldn't have to, well, you do, you can click this, but you shouldn't have to show it like I do. And that was 4508, or just paste it in there, Control V, and then click the I. And we are now finished with this, so I close it back off. And if I zoom in here, you can see that they're a little bit close together. But if I turn the image on, you will also be able to see that it's actually not badly positioned on the bank, but it's just the funny way that the two elements are connected to each other that kind of make it like, if this right bank wasn't sharing with this one and instead it was up here, it probably wouldn't need to extend. But the easiest way to fix it is to just move the bank a little bit. So if I turn on these guys, and then what I'm going to do is turn those on and then turn off the satellite image for a moment so that you can see the vertices a little better. So the problem is the two vertices right here and right here are closer to this point than they are to this point. So that's why the algorithm for the Schematize tool placed the bank right here. So all we need to do to fix it is go into the left bank lines, click Edit, and then use the Vertex tool to put a vertex in this cell. So the way to do that, so here's a vertex that already exists. Here's a vertex that already exists. That's what the bullseye references. And then here is the center line between those two. And if I click the center line, I can now put a new vertex in that line. So obviously I don't want it right here. So I just wanted to show you how it moves. So if I click it again, move my mouse, and then click Final, and what I wanted was a vertex inside this cell. And now when I click Schematize, it'll just reposition the line. So the reason I leave this error in the tutorial is because it's a common error. It's something that you'll see with just about every channel. You'll have to fix a handful of these for just about every channel. And now you see that there's definitely enough space between the left and right bank, and I don't need to do any more changes to it. So I'll just click that and save the edits. And now that I'm actually done with these layers again, so I'll turn those back off. But when I hit the Schematize button, I actually reset all of the data, right? It was that data that we were just looking at before I did the edit was the fully interpolated data. And now that I've hit that schema button, I've changed back to the pre-interpolated schema data, because the schematize doesn't do the interpolation. It just fills in the channels. So we need to repeat this process where I used this button to interpolate the data. So we can go through this a couple of times a little faster just to show you this method. So you click the button, make sure you're in the right location, select the folder, click OK, run the interpolator, click import to get the data back into the geo package, click OK, and now that channel is ready to go. But if you had to make another little change to your data and you had to run the schema tool again, no problem. It's super fast to just run through that interpolator again. It doesn't take very much time at all to do that interpolation. So if you are working with your channel and you are trying to make modifications to cross sections or left and right bank alignments, the first thing you want to do is just mash that schema button, and that will kind of reset everything so that you can't break anything. And then the last thing you want to do when you think your edits are done and everything looks good is to run this interpolator. And of course, you can run that interpolator anytime you want to test the data. So just to be careful and be safe, because I have by now I've totally forgotten where I was. I'm going to hit the schematize just in case, and then run the interpolator just to make sure that I'm in the right location. And that's done. Now, I don't actually have to export the whole project again at this point, because if you were to look at back here in lesson 2, export, that all this data is actually up to date, because the only thing I really made a change to was the chan.dat and the xseg.dat. And you see they have a newer timestamp than the other files. So if I come over here, I can start my test run again. And now it should run. The run should start because we fixed the only bad bank alignment issue. So now just leave this running until it's done, because once it's finished, you can then review the channel. I'm going to minimize that, and I will come back to the lesson to do the final lesson. So the last thing we already did was the final run, and now we need to set up our recovery point. So the final run was just to click Run Flow 2D, set the folder location. Oops, I have a bad image here. I'll go take care of that right now. And if the run still fails or you have more error messages, just repeat step 8, check the error message, fix it, and then repeat the process that we just discussed. All right, so the last thing will be to close QGIS. So click Save, click Close, go back to Lesson 1. Oops, that's not Lesson 1. And then this is my recovery point. So I zip these two together. And then I already have a lesson 2 complete, because I've done this a couple of times to help build the tutorials and whatnot. And I will need to rename this one QGIS Lesson 2A complete. And then to get ready for lesson 3, you just open this QGIS backup. Okay, so that is the end of lesson 2. So please, once you've finished lesson 2, move on to lesson 3. Or if you get stuck or have any problems with lesson 2, send me a text or an email and I can help you get back on track.